Okay, on this question, it says match the three views of this solid to its three-dimensional sketch. Okay, so you have to view these answers down here as three-dimensional figures. And up here, what you're seeing is two dimensions. But you're seeing them from different views. Okay, you've got a front view, top view, and a side view. Now on your front view, what you have to imagine is that you're looking at this figure from out here at the front. Okay? And then you have to think about what it would look like from that front view. And then the top view, you'd be looking down on the three-dimensional figure. And the side view, you're going to be looking at it from probably this right side. Okay? Because on all of these figures, they're kind of showing you the right side of it. They're not showing you the left side. So it's going to be the right side. Now, let's just take a look at these. Okay, if I'm looking at this front view, notice how there's a piece missing here on the top right corner. Okay, if you were looking at this from the front, that top right corner is not missing. There's something there. Okay, so that's not going to be the answer. Now B, you do see that. There's something missing on the top right. So it could be B. Same with C. You got a piece missing right here on the top. Remember, you're looking at it from the front, right here. And then D, you have a piece missing, but it's at the top in the middle, so that's not going to work. So now you want to look at the top view, and you notice on the top view here, you have kind of a backwards L shape right here on the right and on the bottom. And I can see that B has that right there. Okay. C does not. It just has a piece over here on the right. Okay, it has that, but it doesn't have this. So the answer is B. And then the side view, we'll go ahead and look at that. You can see that the side view has a piece missing here on the top left. If you're looking at this from the right side, from over here, and you're looking at this, your top left would have a piece missing right here. Okay, go ahead and try to do this one on your own. Go ahead and stop the tape and work it on your own. And on this one, the answer is going to be B, because you have a circle at the top left corner when you're looking at it from the top. You can see that right there. The front view has a piece missing over here on the top right, there. And the side view has a piece missing on the top left, which would be looking from here. This part's missing. Okay. B is almost correct, but on D, when you're looking at it from the top, you would see a square in there, but the circle's inside. So that's why that one wouldn't work, because you got that square. Go ahead and try this one. For this one, the answer is going to be D. Okay. Okay. Front view, got that piece right there, is here. The top view, this piece is this, and the side view, this piece is this. Okay, number one, if Robert runs 8 times around the circular path that has a radius of 20 meters, the best estimate of the distance Robert ran is, okay, you're going to need your formula chart for this one and your calculator. Okay, we're going around a circle 8 times around a circle. And the radius is 20. So we've got a circle. The radius is 20. Okay. So if we want to find the distance around a circle, we call that the circumference. And the formula is 2 pi r. Well, we know r is 20, so 2 pi 20. And we also know we need to go around this 8 times. And you can go ahead and calculate 2 times pi times 20. And notice that it does say estimate here, so we're going to go ahead and do 2 times pi times 20. And we're going to get 125.66. Okay? Now, we're also told that he goes around 8 times. So we need to take that, and go ahead and just round it to 125 times 8. And that's 1,000. Okay? So let's look at your answers. The only one that makes sense there is 960. Now you may wonder, why was it so far off? Okay, even though it's an estimate, it was a little bit off. The reason is sometimes we're told that pi, an estimate for pi, is 3. Okay, usually they're going to say use 3.14 for pi, but sometimes they'll say 3. Okay, so if pi is 3, 2 times 3 times 20, this would become 120, and then you do 120 times 8, and that would be where you get the 960. But either way, 960 was the only answer that even made sense there. Okay. Looks like on answer B, they forgot to multiply by the 8. So, got to remember to multiply by 8 there. Okay, go ahead and work the others on your own, and I'm going to go over those real quick. Number 2, Tina wrapped a string 1 time around her home. The formula that would be the most useful in determining the length of the string would be, okay, notice these answers. V is volume. This has nothing to do with volume. A is area. Okay, it's not area. S is actually what you use to measure surface area. And if you notice, there's a pi in that answer. And pi is always going to be associated with a circle. So probably not. You're not going to have a circle home. It's possible, but not likely. Usually a house is going to be rectangular. So look at answer D. P is perimeter, and that's exactly what we're asked to find here, the distance around the house. Okay? And that's actually the formula for the perimeter of a rectangle. And a lot of houses are rectangles, so answer D is the one that's most useful. Okay, notice that phrase. Number 3, we have a rectangular lot. That's 400 by 500 feet. Okay. If the large lot is divided into 5 smaller lots of equal size, what will be the area of each of the smaller lots? So there's a key word right there. We're looking for area. So find the area of this rectangle, length times width. You're going to get 200,000 feet, but they're square feet. So 200,000 square feet. Notice your answers are in square feet. Now, there's that answer. Is that what we're looking for? This is the big lot. We're going to divide it up into 5 smaller lots of equal size. So we need to divide 200,000 by 5, and we get 40,000. Number 4. Joshua has a shoebox he wants to fill with dirt. Which formula would be most useful in determining the maximum amount of dirt that Joshua could put in the shoebox? Okay, so we're talking about an amount in a box or in a rectangular solid, any kind of three-dimensional object. We're talking about volume. So we'll rule those two out. Those are both perimeter, where it says P equals. So it's going to be one of these. And once again, notice that right there. Pi. What does pi always indicate? Always indicates some kind of a circle it's going to be in the figure. Okay, so we can rule out answer D. This is a rectangular shoebox. Okay, so, and that actually is how you find the volume of a rectangular solid. It's just length times width times height. You just multiply those 3 things together. Now if you notice on your tax formula chart, the formula is going to say V equals BH, like that. Okay. For a prism. Okay, that's a prism. But what you have to remember on that is that's a very generic formula that works for any prism or cylinder. Okay, including a triangular prism, a rectangular prism, a cylinder. Okay, any kind of shape that's a prism. So what the capital B stands for, and it tells you up here on your formula chart, capital B represents the area of the base of a three-dimensional figure. Well, the base of a rectangular solid is going to be the rectangle that's on the bottom. Okay, so what you do is find the area of that rectangle. That would give you the base of the area of the base. So what is the area of a rectangle? Well, it's length times width. Okay, it's just length times width, and then times height. You take that times height, and that's what our formula says. So that's where the BH comes from on your tax formula chart. Okay. Tony wanted to paint one of the walls in his house. Each can of paint he purchased cost $8.95 and covered 90 square feet of wall. Okay, square feet. As soon as you see that, you should think we're talking about area. Approximately how much did he spend to paint the wall shown below? Okay, so if you're going to find the area of this figure, what you want to do is divide it up into its parts. Okay? I see a rectangle and I see a triangle. Let's take the rectangle. That's the easy one. Area of a rectangle is length times width, and the length is going to be 15, and the width is 10. So that's 150. $150 square feet. Okay, now let's look at the triangle. Area of the triangle. On your formula chart, look it up. It's base times height over 2. Base times height over 2. Now the base is going to be right here, and that's just 15. The height is this right here. That's the height of the triangle. Well, if we know this is 14, and we know this is 10, then the height has to be 4. Okay? So we can plug that in for height. Plug 4 in for height, and then over 2. And do the math for that, and you get 30. So the area is going to equal the rectangle plus the triangle. The 150 plus 30 is 180. Okay. Now it says each can covers 90 square feet. So we need to take 180 divided by 90 to see how many cans we need. And that equals 2 cans. Each can costs $8.95, so we need to do 2 times $8.95, and that gives us $17.90. That's how much you spend to paint the wall. $17.90. Okay, number 2. Same type of problem. You want to divide this figure up into 2 pieces. You could either divide it there, or you could divide it right here. Okay? I'm going to do it this way. If this is 8, and this is 10, then this little piece right here has to be 2. And this is 15, and this is 25, and this piece has to be 10. Okay? So now we've got our 2 rectangles. I'm going to say area of the small and area of the large. The small is just going to be 10 times 2. That's 20. The large rectangle is going to be 25 times 8, which is 200. So our area total is 200 plus 20, which is 220. Okay, now each piece of wood has a dimension of 5 by 2. So what's the area of each piece of wood? The area of a piece of wood is 5 times 2, which is 10. So how many of those pieces of wood do we need to cover this whole wall? Well, we take 220 divided by 10. And that gives us 22 pieces of wood. Each piece is 285. 22 times 285 gives us 62.70. Number 3. Okay. Divide it up. Okay. Each of those little squares is 2 by 2. So each of those is 4. Just going to write those out. And then you've got this bigger rectangle out here. And it is going to be, well, if that's 2 right there, and this is 12, then this has to be 10. Okay. And then we know that's 16. So that rectangle is 10 by 16, which is 160. Add those up. And our total area is 168. Okay. Now, let's look at the tiles. You have this kitchen, and we're using ceramic tiles that are 12 inches by 12 inches. But notice down here, we're using feet. So let's convert those tiles to feet. If it's 12 inches, that's equal to how many feet? Equal to 1 foot. So the tiles are going to be 1 foot by 1 foot. When you multiply length times width of a tile, it's going to be 1 times 1, which is just 1. So each tile is 1 square foot. So you just take the 168 square feet total divided by 1 square foot for each tile, and you get 168 tiles. Each tile costs $3.58, so 168 times 3.58 is 601.44. Okay, the sides of the rectangles can be used to form a right triangle as shown below. Which set of squares could be used to form a right triangle? Now, what you've got to notice here is they're talking about a right triangle. You should know what a right triangle looks like. The only place I see a right triangle here that's being formed by the sides of the rectangles is right here. It's where all those rectangles come together, and they're taking a side from each rectangle to form this right triangle. Your right angle is here. Now remember, your Pythagorean theorem is a squared plus b squared equals c squared, where c is the long side. Okay? So it's also the side that's opposite from the right angle. So this would be the C right here. The other two are the A and B. They could be either one. Okay. So Notice here, this one can't work because you have to have a long side in a right triangle. The longest side has to be longer than both of the other two. Okay? Your longest side here is 5, but you have another one that's 5, so that can't be a right triangle. Okay? The way you test these is you go in with the two smaller sides and you plug them into the Pythagorean theorem to see if it works. That one doesn't work. Just work the math. You get 36 plus 49 equals 64. That's not true. Okay? So those aren't equal. That one's wrong. And you test them until you find one that works. Answer D is the answer because 6 squared plus 8 squared equals 10 squared. If you're not sure, go ahead and check it on your calculator. You'll see that that is true. Okay? So those could be the sides of these rectangles up here that would make that a right triangle. Next one. Same type of problem. Okay. You try out the numbers until you find one that works. And the answer is D, because 4.5 squared plus 6 squared equals 7.5 squared. Work it out on the calculator and you'll see that that is true. Number 2, the answer, it's the same type of problem. They're just asking it a little bit different. These are sticks instead of rectangles. The sticks are going to be the sides of the rectangle up here. And D is the answer, because 6 squared plus 8 squared equals 10 squared. I'm taking this fraction and I'm dividing it by this fraction. So when you do that, you actually take the first one and you multiply it by the reciprocal. So I'm going to flip the 2 and the 1 and make it 1/2. Isn't that what you're doing when you divide by 2? You're just halving something. You're taking half of it. It's the same thing as dividing by 2. Okay? Now look what you got. Pi d squared over 4 times 2 is 8. Okay. And you can kind of see where we're going with this. We've got an 8 in the denominator. C looks like it's going to be the right answer. But what you've got now is you've got d squared plus pi d squared over 8. Okay, let's write all that out again. D squared plus pi d squared over 8. Okay, that's our answer. But we're going to factor out this d squared because there's a d squared in this term. There's also a d squared in this term. We can factor that out. D squared times 1 gives me d squared. D squared times pi over 8 gives me pi d squared over 8. And there's our answer. Now, I know that was a lot of work. If you don't quite understand that one, don't feel bad, don't panic. Okay, this is actually one of the harder problems that you'll be doing. in this study. But you know, if you need to rewind the tape, go over it again until you fully understand that, that would be good. Take it step by step. Okay. Number one, Lewis had edging around a square garden with sides of 11 feet. So, draw this out. Here's his garden. The sides are 11 feet. It's a square. He wants to replace the garden with a circular area for a pool. What is the largest diameter pool he can have using the old edging? Okay. So what we're doing is we're going to use this edging. We're going to reuse it. So we need to find out how much we have. Okay. So you just find the perimeter, and that's going to equal 11 times 4, which is 44. Okay. 44 is the amount of edging that we have. We're going to replace the garden with a circular area for a pool. We're going to use the old edging. Okay, but now we're going to make it into a circle. So our circle, we're using the edging out here. What is this called on a circle? The outside of the circle is called circumference. So circumference is going to equal 44. We need to find out what the diameter is. Okay, so C, let's use the formula for diameter. For circumference. Circumference equals 2, no, look at your formula chart. Pi times diameter. Okay? Pi times diameter. So now we can replace 44 for the C. 44 equals pi times diameter. Solve it for D. So you divide by pi. And 44 divided by pi is going to be approximately 14 feet. Number 2. We got a circle. Circular flower bed has a 4-foot radius. Okay? 4-foot radius. The landscaper wants to redesign the bed to be a square. What is the largest side length of the square bed the landscaper can design so he does not have to buy new edging? Okay, it's the same type of problem. We're taking the edging that's around this circle and we're going to make it into a square. So we need to find the distance around this because we want to know what the outside of this is, how long it is. So we need to find the circumference. Okay. Now we're going to use the formula that has the radius in it. And that is 2 pi times radius. And that's going to equal 2 times pi times 4. That's about 25.13. Okay, so that's how much edging we have. But we want to make that into a square. Well, a square is 4 sides, and they're all the same. So we can just take that number and divide it by 4. And we'll get the length of one side. About 6 feet.